Assalamu alaikum. We are going to continue with the same topic of compaction, and in our last lecture we developed two formulas. You can see that derivation in our previous lecture. Let me summarize it here. So uh, if this is a borrow area, this is the area where the soil will be excavated. So this is a natural soil deposit. This is a natural soil deposit. We want to excavate this soil, so we are going to excavate it with the help of machines. Then this material will be dumped into these dump trucks. So these are the dump trucks. Okay, so these dump trucks are going to take this excavated material, and it will come to the construction site. So mostly this soil will be used as a construction material, so it has to be compacted. So it will be compacted in the embankment. So this is that, what we call it, embankment fill or embankment. So this is actually a fill area. So the general word that we are going to be using is fill, and from here where we take the soil, that is called borrow area. So the soil comes from borrow area, and it is compacted in the fill. Now this embankment could be a dam, or it could be a road project. It could be a fill for the road. So you know that sometimes the roads are in cut, sometimes the roads are in fill. When the road is in fill, we have to bring a material, and we are going to fill it here. So this is a fill material. So the parameters are going to be the density of this borrow area will be called as gamma d of the borrow area. And remember, we always use dry unit weight. Why we use dry unit weight? Because dry unit weight is the weight of solids over total volume. So it doesn't include the weight of water. So the moisture content, or the amount of water in the soil, changes over a period of time, or when the soil is being transported to the construction site, the water amount of water or the water content may change. That's why we never go for unit weight. We always go for dry unit weight. So the dry unit weight of borrow area is gamma d sub b, and the volume of this is going to be vb, and the void ratio is going to be e sub b. And similarly for embankment, it is going to be gamma d fill, and the volume of this hole is going to be V fill, and the void ratio of this compacted soil is going to be E fill. So we derived two formulas in our last lecture. What are those formulas? This is gamma D fill times volume of fill should be equal to gamma D of borrow area times volume of borrow area. And the second formula was volume of fill over 1 plus void ratio of the fill should be equal to volume of borrow area over 1 plus void ratio of the borrow area. So these are the two formulas that we are going to use in our problem. So let's start with our first problem here. So the question here is a soil having a void ratio of 0.68 as it exists in the borrow pit is to be excavated and transported to a fill site where it is going to be compacted to a void ratio of 0.45. The volume of fill required is 2500 cubic meter. Find the volume of soil that must be excavated from the borrow pit to furnish the required volume of the fill. So let's first sketch this problem. So suppose this is our borrow area, and from this borrow area, this is the borrow area, we are going to take soil and we are going to fill it in an embankment. So this is that fill. So that soil will go from borrow area to fill. So it says the void ratio of the borrow area is 0.68. So means the void ratio of the borrow area is 0.68. Okay, and the void ratio of the fill is 0.45. The volume of fill, this embankment, is going to be 2500 cubic meter. Now we have to find out what should be the volume that has to be excavated from this borrow area. Now this is just a one line problem. You know what formula is applicable here? So the formula is going to be volume of borrow area over 1 plus void ratio of borrow area should be equal to volume of fill divided by 1 plus void ratio of fill. Just put the values and simplify. So this is going to be volume of borrow area divided by 1 plus 0.68 should be equal to 2500 divided by 1 plus 0.45. So when we simplify, the volume of borrow area is going to be equal to 2896.6 cubic meter. So this is that volume that we have to excavate. So you see, these problems are not so complicated, just in one line we get the solution. Now let's look at some other examples. Okay, here is another example, and the example is that there is a large dam project is being constructed. The volume of this project is 5 million cubic yard, 5 into 10 raised power 6 cubic yard. And remember that 1 yard is equal to 3 foot. So when the quantities are big, then we, instead of using cubic foot, we use cubic yard. So remember, 1 cubic yard is equal to 27 cubic foot. Anyway, the volume of this project is 5 into 10 raised power 6 cubic yard, or 5 million cubic yard. So this is the volume of the dam, means volume of the dam is the volume of fill, compacted fill. And the void ratio of this fill is going to be 0.8. So these are volume of fill. So this is volume of fill, and this one is the void ratio of the fill. Now you get a task here as an engineer, or your boss is going to tell you these are 3 suppliers and we have to choose which one of them is the best for this project. Now there are 3 locations, 3 borrow areas from where 3 suppliers are going to provide us soil for compaction at different rates. For example, supplier A is going to give us the soil or fill at this rate, 0.6 Omani Real per cubic yard. But the void ratio of this fill is going to be, remember this is the borrow area. So this void ratio that we are going to take from supplier A, it has a void ratio of 0.9. Second supplier B, is going to sell us at this rate, and the void ratio is this much. And third supplier has this rate. So if we look at just the rate, then supplier B looks cheaper because the unit rate is less, 0.4 Omani Real per cubic yard, and supplier A looks more expensive. So you are not going to decide based on the unit rate. We are going to decide based on the total cost, because the void ratios are different. If the void ratios are different, total volumes are going to be different. So we are going to find out the total volume, and then using the unit rate we are going to find out the total cost, and from the total cost we are going to decide which supplier is going to be more economical. Okay, let's start this problem. Okay, so let's first sketch the problem. So there are going to be 3 borrow areas. I'm just going to make just one sketch, and this is that dam that is being constructed. So this is the dam, it is the fill. So you can call it fill or dam, it's same thing. This is fill and this is borrow area. So the volume of this fill is 5 into 10 raised power 6 cubic yard, 5 million cubic yard, and the void ratio of this fill is 0.8. And the borrow areas, so the volume is going to be volume of borrow area and the void ratio is going to be void ratio of the borrow area. Now there are three borrow areas. So one is borrow area A. So supplier A, our borrow area is same. Let's say borrow area, let's say 1 or A, whatever you want to say. So this first supplier has this soil has the void ratio of 0.9, and the rate is going to be OMR 0.6 per cubic yard. So let's go back and see. So the first supplier A, the rate is 0.6, void ratio is 0.9. So instead of 1, let me write this also. A, borrow area A. Okay. So the formula we know is the volume of borrow area over 1 plus void ratio of borrow area should be equal to the volume of fill over 1 plus void ratio of the fill. So this is the formula that is applicable here. So what will be this volume of borrow area should be divided by 1 plus 0.9 should be equal to 5 into 10 raised power 6 divided by 1 plus 0.8. So if we simplify this, so the volume is going to be, volume of borrow area is going to be 5.278 into 10 raised power 6 cubic yard. Now we know the total volume that is needed for this project from borrow area A. So what will be the total cost? So the total cost is going to be equal to total volume times the rate, what we call it unit rate, the rate for unit volume. So the total volume is 5.278 into 10 raised power 6, and this unit, remember, is cubic yard. And what is the unit rate? Unit rate is OMR 0.6 per cubic yard. So you see, this cubic yard and cubic yard is going to cancel out. What is left is the amount. So when we multiply this, this is going to be 3.17 into 10 raised power 6. Here is OMR, means we got the rate. So let me summarize here. So supplier A, supplier B, and supplier C are borrow area A, B, C. So the first supplier, the total rate comes as OMR 3.17 million. 3.17 million. So 10 raised power 6 is million. So this amount is 3.17 into 10 raised power 6 or 3.17 million Omani Real. So this is the total cost if we pick soil A or borrow area A. Now let's look at borrow area B. So when it is borrow area B, so if you go back and see, for borrow area B, the rate is 0.4 and void ratio is 2.0. So the void ratio of this borrow area is 2.0. So what is going to be that volume of borrow area? It is going to be volume of borrow area over 1 plus 2 should be equal to 5 into 10 raised power 6 over 1 plus 0.8. So if you simplify this, second, volume of borrow area is going to be equal to 8.33 into 10 raised power 6 cubic yard. So we can calculate the total cost, just multiply with the rate, and the rate for this This site is okay. Let's see what is the rate. The rate for this site is 0.4. This is the cheapest one. Unit rate is less, 0.4 OMR plus cubic yard. So the total cost is going to be, you have to do what? You have to multiply the volume with the unit rate. So when we multiply, what we are going to get is OMR 8.33 million. So if we pick this site B, then the rate is going to be, okay, there is a mistake here. 8.33 was the volume. We have to multiply this 8.33 with the 0.4, so it is going to be 3.33. So this is going to be equal to OMR 3.33 million. Now let's look at borrow area C. For borrow area C, let's go back and see. The void ratio is 1.6 and the rate is 0.5. 1.6 and the rate is 0.5 real per cubic yard. So let's calculate the volume. So this volume is going to be 1 plus 1.6 over 1 plus 0.8 times 5 into 10 raised power 6. I just put the values directly. So this volume comes as 7.22 into 10 raised power 6 cubic yard. So what is going to be the total cost? Total cost is going to be the rate. Rate is 0.5 times 7.22 into 10 raised power 6. So your answer is going to be OMR 3.61 million. So this is OMR 3.61 million. So if you look at now the summary, the site A comes out to be most economical. Why? Because the total cost is less in this case. So this site A, the total cost is going to be 3.17 million. So if you pick this site A, the cost of fill is going to be 3.17 million. This is the cost on the material. However, this A had the maximum unit rate. So if you look at only the unit rate was maximum. So you never decide based on the unit rate. You are going to decide based on the total cost. Okay. So this was the question. So in this case, you are going to do this calculation and you are going to give your recommendation to your boss that site A or supplier A is most economical. Okay. Next question is, based on the previous problem data, if the fill dumped into the truck has a void ratio of 1.2, how many truckloads you are going to need to fill this dam? So if you remember the previous problem, the void ratio of the dam is 0.8 and the volume of this dam is 5 into 10 raised power 6, right, cubic yard. And if you remember, we selected this supplier A. Supplier A was the most economical, so we picked this supplier A. So this supplier A, if I go back to this question, supplier A has a void ratio of 0.9. So this void ratio of the borrow area is 0.9. So this is that borrow area that we selected or we finalized, and this is the fill. Okay. Now when the soil is excavated, it is going to be placed into this dump truck. So when we excavate this soil, the soil gets in loose state. So the void ratio when the soil is in the truck is going to be 1.2. This is given. So the void ratio of the soil in the truck is equal to 1.2. Now the volume of this truck when we fill it one time is 10 cubic yard. So when this truck is full of soil, it can carry a volume of 10 cubic yard. Now the question is, how many truckloads are needed? I mean, if there is one truck, how many trips this one truck is going to make in order to complete this fill? So this is called truckload. So how we are going to solve? Let's look at it. Okay, we have calculated in our previous question the volume of this borrow area. So if you go back and see the previous question, the volume of this borrow area was 5.278 into 10 raised power 6 cubic yard. So if you go back and see, this was the volume for borrow area A. This is the soil that has to be excavated from borrow area A. So this is the same volume that I have here, okay, from this borrow area A. Now the question is how many truckloads are needed. So it means now we are going to talk about the borrow area and the truck. So the formula is same. So I can say that if this is the volume of the truck and this is the total volume of, this is the volume of the truck. So we are going to use the same formula. Okay, volume of because both of them are, this is not the fill, let me call it as volume of B over 1 plus EB is equal to the total volume that the truck has to carry. Let me call it as VB2 over 1 plus EB2. So that total volume that truck is going to carry out is going to be 5.278 into 10 raised power 6 divided by 1 plus 0.9, and here is going to be 1 plus 1.2. I just put these values. So this is going to be equal to 6.11 into 10 raised power 6 cubic yard. So it means if the volume of that volume we have to carry we have to excavate from the borrow pit, it is going to be 5.278 million cubic yard, but that volume that the truck is going to carry is going to be 6.11, and when it is going to be compacted it will become 5 million cubic yard, because the volume in truck is going to be less dense. So the soil is going to be less density, that's why we need more volume in the truck to be carried out. So this is that the soil that the truck is going to carry on. So the truck has to carry a volume of 6.11 into 10 raised power 6 cubic yard. Right now the volume of truck is only 10 cubic yard. So it means truck cannot take this whole soil in one go. So how many times this truck needs to fill? So the trips of the truck, if we have just one truck, the trips of truck is going to be equal to 6.11 into 10 raised power 6 cubic yard divided by 10 cubic yard. This is going to give us 6.11 into 10 raised power 5 passes. Right? It means if we have just one truck, then that one truck needs to go 6.11 into 10 raised power 5 times. So this is called truckloads. So truckloads is going to be equal to 6.11 into 10 raised to the power 5, or you can write it 6.11 10 raised to the power 5, it becomes 611,000 trips. So if we have just one truck, this truck needs to go 611,000 times, then it is going to fill this dam. So definitely our trucks are going to be more than one. So on the big projects, the trucks that are being used for transporting the soil, they might be in hundreds or maybe in thousands. So in that case, every truck is going to go less number of times. So from there you can easily calculate, if you have 100 trucks, then how many times one truck needs to take this soil. Okay. Now let's look at one more problem. Okay, you can do this question, very easy. We did this question in the beginning of this lecture. You can try it yourself. There is one more question. This one, this example, again you can do it yourself. We have done similar example. So these are some of the questions that we normally deal with in compaction. Now let's look at the modified Proctor test. This modified test I already discussed in previous lecture. So in modified Proctor test, we give more energy to the soil. So if this is a standard Proctor test, we are going to get this kind of shape. And for modified Proctor test, we are going to get more density, and that more density will be achieved at less water content. Okay, so in modified Proctor test, the mold is same, 1/30 cubic foot is the volume, but the hammer is going to be 10 pounds, and the drop of hammer is not 12 but 18 inch, and we do not compact in 3 layers but 5 layers, and each layer is compacted 25 times. So if we calculate this energy, so you know how to calculate the energy. So the energy is going to be, let's say, energy for standard test. So what will be the energy for standard test? So we have to look at what is the hammer is 5.5 pounds times, and the drop is 12 inches. 12 inches mean 1 foot. So when this hammer is dropped one time, this is the energy, 5.5 pound foot. Now this is going to be compacted 25 times. So this is going to be energy given to one layer, and we compact it in 3 layers. So you have to multiply. So means the total energy that is given to the soil is 25 times 3 means 75, and we have to divide it with 1/30 cubic foot. So when you calculate, it comes as 12,375 pound foot per cubic foot. So this is how we calculate this energy, and similarly you can calculate the energy for modified test. So if you find out the ratio, so this has 4.5 times more energy as compared to the standard test. So this modified test mostly we do not use in our normal projects, but if the load is very heavy, then we are going to use this modified Proctor test. Mostly this modified Proctor test is used in the construction of the embankments, or in the construction of airports, where the load is very heavy. Okay, now the next topic is the field compaction equipment. These are the family of earth moving equipment. The trucks, this is dump truck, or simply you can call it truck. This dump truck is going to bring the soil from the borrow area to the construction site. Okay, and these are the excavators. No, just this is called roller. There are different type of rollers we are going to see. This is again a roller here. Okay, and these are called bulldozers. Okay, so they are chain mounted bulldozers. If you look at here, this is a chain here, CHAIN. It has a chain. So these chain give it stability, and it can go into in any area, and it is going to be stable. So they are not rubber mounted, tire mounted. They are chain mounted bulldozers. So these bulldozers, they have a blade here. If you look at, there's a blade here. So this blade is going to help us in spreading the soil and leveling the area. So these are some of the equipment that is used in the construction. Okay, now one of the equipment is called scraper or scarifier. Scraper or scarifier. Now what is a scraper? When this equipment is moved, there's a blade at the bottom. So there is a blade at the bottom. So when this equipment is going to move, the soil will be cut, and that soil is going to be filled in this area. So that soil, when it is moving, so the blade is going to cut, and that soil starts getting in it. So when this is totally completely full, then this scraper or scarifier is going to go to the area where it is going to dump this soil. So in one go, it can cut a soil up to 8 to 24 inches. 8 to 24 inches. It can excavate up to 2 foot. Okay, so these are one of the equipment, and this is one equipment that is going to cut the soil, that is going to transport the soil, and then it is going to drop the soil. Okay, you might have seen these motor graders mostly at the road projects. So there is if you look at here, this is that blade that is used to make the gradient of the project of the either it is road project or whatever. So if you know in the road project, you might have this kind of slope. So these are the slopes. If this is the center line of the highway, then how we are going to achieve this slope? This is with the help of these graders, motor graders. So these graders are going to displace the soil, and they are going to make the desired slopes. Now when we are compacting our soil, we have to do it at a certain water content. And if you remember, we did one question in our last lectures. If this is our maximum dry density, gamma d max, and if this is the optimum water content, we cannot achieve 100% density. So we are going to try to achieve, let's say, 95% or 98%. Suppose this is 98% compaction. 98%. So if we are going to achieve 98% compaction, then this is going to be the water content range. So this is the water content range for 98% compaction. Water content range for 98% compaction. Now, so you know what is the water content range. So how we are going to maintain that water content range? So when we are filling this area, and we are compacting this soil layer, we are going to use these trucks, water tanks or water trucks, and these trucks are going to sprinkle water to attain the optimum water content. Now, because this is not just one value, and it is a wide range, so any water content which is within this range should be fine for compaction. And with the experience, the workers or the foremen who are working on the site, they very quickly understand what is the moisture content at the moment. Okay, and they are going to help us during the construction. Okay, Now let's look at the compaction equipment. So we have a number of compaction equipment. The most common is this smooth wheel roller. Then this is a pneumatic rubber roller, sheep foot roller, tamping foot roller, vibratory roller, impact roller, and grit rollers. So the most common is going to be this smooth wheel roller. So smooth wheel roller is going to cover 100% of the area. So you see this is a smooth wheel. So when it is in contact with the soil, it is covering 100% of the area. So the area that is being covered is 100%. So that's why we have 100% coverage. And the pressure that it is going to exert on the soil is going to be almost 380, or I can say 400 kPa. So almost 400 kilopascal is the pressure that this roller is going to exert on the soil. So it is going to be used for any kind of soil. This smooth wheel roller can be used for any kind of soil, but it is not used for rocks. It is used for all kind of soils except for rocks, and mostly it is used for proof rolling. I mean, when the compaction is completed, then we are going to use this roller to make the smooth surface. Okay, and this is not suitable for compacting thick layers. Now second kind of roller is called pneumatic rubber tired rollers. Pneumatic means pressure. Pneumatic means pressure. So these are the rubber tires, they have pressure in it. So if you look at, there's some space between these tires. Since there's a space between these tires, so the coverage is not going to be 100%. So the coverage is going to be 80%. And the pressure it exerts is up to 700 kilopascal. So remember, for smooth wheel roller, it is 400 kilopascal. And for the rubber tire, it is 700 kilopascal. I can say almost it is almost double. Uh, Mostly we use this for granular and cohesive soil, but you might see this mostly on the road projects where the top layer is being placed, where the asphalt layer is being placed. So that is used for the construction, the compaction of those asphalt layers. Now the third type is sheep foot roller. The name comes from why we call it sheep foot roller. But if you look at the sheep, they have very small foot, and when the sheep is moving, the cattle are moving in an area. With the help of their foot, they are going to compact the area. So the idea comes from there, and that's why we have these projections. So if you look at this figure, so these projections look here. So when this roller is going to move, it is going to cover only 8 to 12%, or I can say it covers only 10% of the area, because the area is small, and pressure is equal to load over area. So when area is less, the pressure is going to be more. So it can exert a pressure of almost up to 7,000 kPa. Look, smooth wheel roller can exert a pressure of almost 400 kPa. So that rubber or pneumatic roller, that exerts a pressure of 700 kPa, and this sheep foot, it can exert a pressure up to 7,000 kPa. So you see the pressure is very high, 7,000 kPa. So it exerts a lot of pressure as compared to the smooth wheel roller. So the pressure that it exerts is more than 10 times. So in case of smooth wheel roller, if we compare it with smooth wheel roller, it is almost 15 to 20 times more pressure. And when we compare it with rubber roller, it's almost 10 times. So what happens is, when okay, let me insert one slide here. So suppose this is the that wheel, and it has a lot of projections. So these are the projections of the roller. If the soil is loose, so what is going to happen is that suppose this is that soil, and the soil is loose, so all these projections are going to go into the soil, and these projections are going to compact this layer. And when we keep on passing, so these layers start getting compacted, and there will be a time when this roller is not going to go in. So when the soil is fully compacted, at that time the projections are going to be like this. So in the beginning, these projections will penetrate into the soil, and slowly and gradually they will come out, and when the soil is fully compacted, so these projections are not going to go into it, and in this process the soil gets compacted. And mostly we use this roller for cohesive soil. And how we are going to decide if we are going to use this roller or not? So we have to look at what is the passing from 200 sieve. If you remember, passing from 200 sieve is called fines. So if passing from 200 sieve is more than 20%, then for that soil we are going to use sheep foot roller. So this is a thumb rule. Mostly we use, if fines are 20% or more, then go for this roller. Okay, so here it is. So fine grained soils, if they have fines more than 20%, we are going to use this sheep foot roller. And you can see here in this picture, when this roller is passing, so you see these are depressions. So what is happening in these depressions? The soil is being compacted. So when the soil gets compacted, every time when this roller is going to pass, these projections are going to penetrate less into the soil, and in the end it is going to be something like this. Now there is another roller which is called tamping foot roller, and it is same as sheep foot roller, but the only thing is these projections are going to be big. So these projections here, they are big. So the coverage is 40%. It is not 10%, 40%. And the pressure, it can exert up to 8,000 kilopascal. Again, it is used for the fine grained soils. There is another kind of roller which is called impact roller, and these impact rollers, if you look at the shape of this roller is not circular, it's kind of triangular shape, and some of them have this 5 edges, pentagon shape, this kind of roller. So when this roller is going to move, it is going to apply a load that is going to be impact load. So some of them are having 3 sides and some of them having 5 sides. This is 5 sides. So it is going to apply energy with the impact, and with that it is going to compact the soil. So this is a 5-sided impact roller. Now any roller can be converted into a vibratory roller. So smooth wheel roller, sheep foot roller, tamping foot roller can be converted into vibratory roller. What we do is we are going to attach a vibrating system. So a vibrator is going to be attached. So if the vibrator is attached, so suppose we have here vibrating system. So when this vibrating system is not working, it is going to work as a normal roller. But if we are going to turn on this vibrating system, so the roller, when it is going to move, it is going to compact the soil, and when it is vibrating, it is going to compact with the help of vibration. And remember, these vibrating rollers are excellent for sands and for granular soils. Okay, so this roller is excellent. So any roller with the vibrating system is good for for granular soils, especially for sands. So any roller can be converted into vibratory roller. The only thing is we have to turn on the vibrating system. Okay, so the next one is called grid roller. So there's a grid, and these are not very common. So you might see this grid. So this grid is going to be used for mostly the soils that have a lot of rock in it. So if there are some soils that contain big pieces of rocks, then we are going to use this grid roller, and it covers 50% of the area, and the pressure can go up to 6,000 kilopascal. Mostly this is used on the big dam projects. So you might not see this roller on a highway project. Now, if we are compacting in a limited area, for example, it's not a road project, but it's, for example, a structure. It could be a building or it could be any other structure where we have to compact some soil. Then we are going to use these plate vibrators. So these plate vibrators are used for backfilling, for example, any trench. For example, we are uh, placing some pipeline, and for that pipeline we excavated the soil, we make this trench, and then in this trench we are going to place the pipe, and then after that we are going to backfill this material. So here, what kind of compaction material equipment we are going to use? We cannot use here rollers or something, so we are going to use these handheld compactors. So these are called plate compactors, or sometimes this is also used in the buildings. So here is the summary. The summary is, if we are dealing with the clay, then we are going to use sheep foot roller, and sheep foot roller is used if the fines passing 200 is 20% or more. So then we are going to use sheep foot roller. But if the soil is granular, then we are going to use any roller but with vibration. Okay, and if we have rocks in our soil, then we are going to use the grid roller. So the decision is based on the type of soil and the percentage of fines in it. If the fines are more than 20%, go for sheep foot roller. If the fines are less than 20%, then go for smooth wheel roller or any other roller, but use the vibration. If the rock pieces are more, then use the grid roller. So this was the very brief summary about the equipment that we used in the process of compaction. So I think this is enough for today. So we are going to continue with one more thing, which is the field density test, in our next class. Thank you so much and have a great day.